Welcome to the Math 1 extra support video on arithmetic sequences.
So an arithmetic sequence is a list of numbers in which the difference between one term and the next is constant. That is, the next number in the sequence is determined by adding or subtracting a constant amount to the previous number. So let me give you an example before we talk about what a common difference is. So this is an example of an arithmetic sequence. And so we have, say I started at 6 and I'm adding 5 each time. So I go to 11 and then to 16 and then to 21 and it continues on. So that's an arithmetic sequence because the next number in the sequence is determined by adding 5 to the previous number. So let's talk about this idea of common difference. The common difference is the constant number being added or subtracted in an arithmetic sequence. And subtracted is in parentheses because subtraction is just adding a negative. So we can really think of it just as adding. That's the official definition. So we have common difference is usually referred to as D. So in this case, D would be 5. Now, if I go and give you another example, let's say I'm starting at 100 and I drop to 98, then 96, then 94. This is an arithmetic sequence. Starting at 100, we're subtracting 2 every time. When we write the difference, we write it based on the adding aspect because remember, subtracting is the same as adding a negative. So in this case, we're adding -2. So the difference is -2. Those are both arithmetic sequences. Now, we can represent the function formulas for these sequences in 2 different ways. One is recursive. So a recursive formula is a formula which, based from a starting value, describes how the next number in the list will be determined from the previous number. So one way you'll see a recursive formula written is using this template here. So if I take example 1, 6, 11, 16, 21, it usually starts with x sub n equals x sub n minus 1. So what that means is if n is 10 and I want to know the 10th number, then 10 minus 1 is 9. I need to do something to the 9th number to get to the 10th number. And so how do I get from one number to the next in this list? Well, we said we added 5 each time. So that's the way that it would look at. But notice it also said based from a starting value. So I need to say what the first number was in the list. So I'm going to call it x sub 0, meaning the 0th term in the list, which may not seem significant right now, but you'll understand in a few lessons why that's important. So if x sub 0 is 6. Another way you'll see this written, and this is more, so that's kind of the state of North Carolina notation. This is the MVP notation. It means the same thing. It's just written slightly differently. And so instead of x sub n, we just write f of n and f of n minus 1. So it's still saying the same thing. It's saying the next number is based on the previous number and then something that's happening to it. So what was happening each time here? We were subtracting 2. So we could put -2 or plus -2, but -2 is more math swaggy. So in this case, f of 0 instead of x sub 0 would be 100 because we started at 100 up here. So again, those notations are both recursive notations, but I wanted to show you both types that you'll be seeing in class versus on the homeworks. Ready, set, goes. Now we can take each of these and we can also write an explicit formula. So an explicit formula is a formula which describes how to find the number of a sequence based on the nth term. Glitch, 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 sorry. We would have f of n. For first example, we were starting at 6, so 6 plus 5n. And let me just kind of show you how this works. So we know that the 4th number in the list is 21. So f of 4 would be 6 plus, oh sorry, so this is where the 0 becomes important. So if this is the 0th number in the list, that would actually be the 3rd number, f of 3. So it would be 6 plus 5 times 3. So the 0th term, 1st term, 2nd term, that's the 3rd term. And that would be 21. So it matches and the formula works. In example 2, the explicit formula would be f of n equals So starting at 100, subtracting 2 times n. And so we already know that the third number in the list is 94. So again, the reason that's the third number of the list is because we said that we're starting at f of 0. So this is the 0th term, first term, second term, third term. So f of 3, to test our formula, should be 100 minus 2 times 3. Does that? That's 100 minus 6. That does equal 94. So we verified that this formula is correct. So explicit formulas are beneficial because I could find what the 500th term in the list would be quite quickly. Recursive formulas are much more intuitive and connect easier to your learning up to this point. All right, more to come in the next video. Thanks for watching. If you need help with the Ready, Set, Go homework specifically, please make sure to check Canvas student support site for Ready, Set, Go videos made by MVP.